Good evening, friends. Today I am going to discuss about the K-means clustering. K-means clustering is a unsupervised machine learning algorithm. It is very useful for clustering the data on the basis of their similarity and their property when we have higher dimensional data. So what happens is that in this we first decide that how many clusters we are going to make, deciding the number of clusters. So what we do is that let's imagine that four clusters we are going to make a data. Okay, four clusters, or let us take three clusters and use more. Suppose here is our data, that is the test point. We can even represent it like this also. So what happens is that suppose we are going to assume then that three clusters are going to be formed. So what happens in the step one is that initially random centroid are selected, like random points are selected at the centroid. Suppose this is selected as centroid, this is selected as centroid, and suppose this one is selected as a centroid. Then what happens is that we make clusters. What we will do, we will calculate the distance of each of the data point from each of the cluster, and suppose this data point is closer to this one, then it will be part of this cluster. Okay, similarly the data points are measured distance through Euclidean distance, and the smallest distance from the cluster of the point will be the mean group where the point will form a cluster. Now suppose that these points form a cluster here, these points form suppose a cluster here, and these points form a cluster here. Then what we do? So first of all we assume that we are going to make three clusters, then randomly three points are selected as the centroid, distances are measured from each point from the centroid, and the point which will be nearest to the centroid will be part of that cluster only. Then what we do, we again recalculate the centroid. For this data set, what we do is that here will be some y, here will be some x. What we will do for this particular points which are coming in this cluster, we will find the mean of the x values for these respective data points and the mean of the y values for these respective data points, and we will find a new centroid points, like suppose here, and for this we find a point suppose here, and we for this we find a point suppose here. Then what we will do, then again the same process will be applied, and the points will be assigned a clusters. Now suppose this forms a one cluster, this forms a second cluster, and all this forms a third cluster after updating my centroid. Now what will happen is again the centroid will be moved. Now if you will check now the centroid, suppose I try to move the centroid but the centroid remains at the same position. So what will happen, the cluster will also not change. So in such cases we have reached our final place where our most efficient clusters are made. Okay, so you must have got how the points are clustered. It is done on the basis of the distance from the centroid. In the initial step the centroid is selected at a random. In the other checking process we find the centroid by the mean coordinate for the y point and mean coordinate for the x point for all the data points that comes in a particular cluster. So I have told you till here that how do we make the cluster and how we check whether we have reached our final cluster or not. Now let me tell you how do we decide that how many clusters are going to be made. It is decided by the use of the elbow curve. What we do is we put our WCSS value here and number of clusters here. So suppose 1, 2, 3, any much clusters which I want to make. Okay, so suppose a data set has n data point, then how many maximum clusters can be made? N clusters can be made. Each point can be considered as a cluster itself. Now how does the WCSS value is defined? WCSS value defining is very small, easy. Suppose that I have this is my data points, and I suppose that I am going to make only one cluster. Then what will happen? A centroid will be assigned, and then distance of all these will be calculated from the centroid. D1 square plus D2 square plus D3 square till Dn square. Okay. So the summation of all these values will give me the WCSS value for number of clusters is equal to 1. Now suppose for this data points only I decided that I will make two clusters. So I decided this and this. Here centroid will be here the centroid will be somewhere here. Again the same process, D1 square plus D2 square plus D3 square, D1 square plus D2 square plus D3 square. WCSS value for this clusters will be calculated different. WCSS value for this cluster will be calculated different, and then both of these value are added and we get the final WCSS value for our number of clusters is equal to 2. So if you will plot the graph, you will get to know that the graph goes something like this. The graph goes something like this. As you reach towards the n value, the graph tends to 0. Okay. Now what is the elbow point here, where you see that the change in the WCS value is not significant, that it starts being in a constant type. That point is considered to be a elbow point, and here it is what, here our 2 is our elbow point, which you can see. Because if I'm increasing my cluster, the change is not that much significant. For example, just see here 1 and 2, a lot of change, but from 2 to 3 a slight change, 3 to 4 a slight change. There are no more, not a great difference is seen between the WCSS value. So the point which is considered as elbow point, and this tells me that, and the elbow point here is 2. So for this particular data, number of clusters is equal to 2 will be preferable. I have just supposed an example. So you must be clear that how does our k-means clustering work, and how does the elbow point is considered, and how do we calculate the WCSS value. Thank you.